I'm Liz Abinante. I don't expect you to ever pronounce my name correctly. Nobody does. But I'm here to talk to you about why you should teach kids JavaScript. If you don't have your own kids, you can totally borrow someone else's. Just make sure you have permission first. And my number one goal of this talk is to not mention Ember. So we're going to cover... I'm sorry, I just had to say it. We're going to cover what JavaScript actually is, because I'm pretty sure nobody knows, why we actually should teach kids programming, why specifically JavaScript, and how to prepare yourself your own hacker army. So let's talk about JavaScript for a little bit, because we haven't been doing that at all today. JavaScript has many flavors, just like ice cream, and you can enjoy the flavors alone or combined in many different ways. And that's kind of what makes JavaScript so great, is you pick your flavors. There's no one right way to do things. And sometimes that's great, sometimes that's terrible. But it's still what makes JavaScript so fun. And oftentimes, I don't know how often you guys use this word, but I use it a lot, vanilla JavaScript, to talk about just JavaScript by itself, nothing fancy, no libraries, no jQuery, nothing. And this could be anything, design patterns, functional JavaScript, even vanilla JavaScript itself has tons of different flavors. You can get that artisanal vanilla bean ice cream in there, or just regular vanilla JavaScript. It's totally fine. But I was making these slides and I was thinking to myself, when was the last time I wrote JavaScript without a library, without jQuery or underscore or a framework, or without CoffeeScript? And we all started with spaghetti code, with anonymous functions, and tiny things like this, which are super, super simple. But now we've moved on so far beyond this that sometimes we forget about the basics. And that's not bad. It's just, this is the kind of JavaScript that you learn when you're brand new to the language. And this is the kind of JavaScript that ultimately you want to teach to kids. So why? Aside from the fact that children are our future, there are actually some legitimate reasons why you should teach them. So technology is constantly changing, which is pretty obvious. But the jobs that most of us have today are for companies that are in a field that didn't actually exist when we were in junior high, or even for some of us in high school. We're using tools and languages that did not exist 10 years ago. And if they did, they're completely different than what we use today. And there's no way really to predict whether or not learning JavaScript is going to help them in their careers in the future, but preparing them for a tech-heavy or computer-based career won't hurt kids. If anything, it'll improve it. Just make sure you don't forget to teach them how to read and write and math and stuff. It's still kind of important. I don't know if you guys took 10 key in high school. I did. 10 key data entry, with the full keyboard. Did it help me in my career? Nope. Not at all. But it did introduce me to the banality of data entry, which piqued my interest in automation, which in the long run brought me into programming. So thank you, high school 10-key teacher. Typed in all those credit card numbers. Oh, I would never do that again. And so while learning a language, a specific language, or even a specific skill might not be directly applicable in the future, they're getting a technological foundation that is invaluable, regardless of your age and regardless of your career. So this is kind of a no-brainer. But the earlier that you start learning something, the more concepts you can learn before you eventually kick the bucket. And, really, you gotta up-talk the death thing, guys. It's often said that it takes about 7 to 10 years to master something. So if you started writing JavaScript when you were 10, 11, maybe 13, you'd have mastered it by the time you graduated from college, if you chose to go to college. And if you've mastered this one skill or this one programming language during that kind of short period of time, you're doing pretty well for yourself. That's pretty awesome. And imagine how different your life would be, your life specifically, if you had learned these concepts when you were really young, like a toddler or in elementary school, or even if this was included in your junior high school curriculum. You would know so much more than you do now, but also you could do so much more than you know now. And that's the real big benefit of teaching kids. If you start early, they become entrenched in technology. They become entrenched in the terminology, and they could create new theories. They can solve these unsolvable problems that all of us who've been educated in somewhat similar ways haven't been able to solve yet. They could figure out how to terraform Mars with JavaScript. Who knows? But unlocking potential early leads to a greater lifelong benefit for the community as a whole, especially when you take into account open source software. I put glitter on this slide to try to make this less depressing, and I'm really sorry, but adults are kind of terrible programmers. Only kind of. We're not that bad, but we are limited in our abilities. We're limited by, a lot of stuff, really. Our education, our ability to learn new things, the number of hours in a day, the responsibilities we have as an adult. But really, when I sit down and I start working on a new problem, or I'm working on a new code challenge at work, I always worry. And that worry comes from fear. Adults are very inhibited by our fears. We're not terrible programmers. Sometimes we just worry. We're worrying that we're going to be mocked or that we're going to fail. We're afraid of being wrong or breaking our company's entire app, taking too long to ship. I've had many friends complain to me, I haven't shipped anything in weeks, I feel like a failure. Or just plain not being smart enough. And these are things that are really, really hard to talk yourself out of. They're things that are in your brain, and you worry that people think these things about you too. So we try and we try and we try, but it's always a little scary. And if it's not scary, please tell me how that works. I need to know. But I think the number one reason that adults are terrible programmers is because we lack the pure imagination of childhood. Our problem-solving skills are limited by our lack of imagination, which is kind of directly related to creativity. Really, when was the last time you had an exclusive A-list tea party for all of your toys? When was the last time you put on a mismatching outfit and trotted around the house and let your parents take pictures of you? Probably not yesterday, probably not in the past 10 years, but these are things that kids do every single day. These are things that their minds just naturally think of, things that are so different from us that we would never think to go there. And even though throwing a tea party for your toys may not make sense when you think about problem solving and programming, but that different perspective that they have, that they approach the world with, you can teach them and shape them like little balls of clay to apply that to programming. And somebody quoted Albert Einstein today, and I was very upset, but it's okay because it's a different quote, so no more anxiety. But Albert Einstein said the super great thing about imagination, and you can all read, I'm hoping, so I don't have to read you the whole thing, but imagination at the end of the day is a lot more important because it's unlimited. Imagination is only limited by how much you can think, how long you can think for. And my imagination is different than yours, just like ours is different than the kids of the world. And so the imagination and creativity that children have conquers their fear. I mean, could you imagine if you put on that outfit that you wore when you were 2, that was like one of your mom's shoes and one of your dad's shoes and like your dad's work shirt? Apparently I'm the only person that did this. And you walked around the house for like 2 hours when all of your relatives were over. And it wasn't embarrassing to you as a kid, but if you came to a conference and were wearing something weird and people started looking at you, you would get embarrassed because you're afraid. You're an adult, totally normal to be afraid. And because children have that imagination in spades, their little tiny brains are perfectly suited to be molded to make a tiny hacker army. They see things differently, and they think differently. So, ergo, they approach problem solving differently. Their wee, tiny, itty-bitty minds have not yet been taught how to, or more importantly, how not to, do things the right way. They just do them their way. They just think of it. I wouldn't think to wear one pink rain boot and one yellow rain boot, but I nannied a 3-year-old and she wore that every day when it rained, so there you go. It was her thinking about how things match. And it's not stubbornness. Kids can be stubborn, but that creativity is not stubbornness manifesting itself. It's just them playing with the world. And so we can teach these kids because they're little imagination bombs and they're going to bring all these great ideas to programming, right? Right. But why JavaScript? Why not something else? Why not Ruby or Python? I'm a Rubyist, and when I said I was giving this talk, a lot of my friends were like, really? You're going to bash on Ruby? But I'm not bashing on Ruby. I think Ruby's a wonderful language. However, Ruby and Python typically require a complex system setup that, to many of us, is not as complex, but nevertheless, it is a road bump you have to get over, and you generally need slightly more expensive hardware. And even though you can do Ruby and Python development in the cloud now for free, for next to nothing, they're still not as visual as JavaScript. And JavaScript really, really excels with visibility. It's why we're all here. It's why we use it for our user interfaces. It makes visual things more compelling. And because it's a language of the web, you get that instant gratification. You get that visual instant gratification for kids. And that's a huge motivator. They see what they do. And for us as an adult, it's totally fine to tinker around in console and see words and data structures and, variables. But kids don't care about variables. Why do I care that my variable is assigned to red? I want to see the color red. And last but not least, a lot of people don't like JavaScript because of the curly bracers. But you know what? It's good for the soul. It really is. It keeps you grounded. That syntax can be your touch point. You check in to make sure that everything runs smoothly. If you get errors, sometimes it's your syntax, sometimes it's because you make typos a lot like I do. But it also helps to teach new programmers to be slightly more meticulous with their code. They have to remember both sets of those curly bracers. They have to remember that semicolon. And while not every language has that type of syntax, so many do that we shouldn't run away from that when we're teaching kids, and we certainly should not hide it. You don't want to bias somebody against syntax just because it's a little scary. Just a little. So I've convinced you, hopefully, that it's not Ruby and it's not Python. It should be JavaScript. But why? It introduces kids to the web, but also core programming concepts at the same time without getting too complicated too quickly. So you can start with a minimal scope, or small scope and minimal tools, increasing your stack with complexity as the child learns and as the child grows. You start with just that vanilla JavaScript we talked about earlier. Nothing fancy, but it's good for you. Write it. It'll make you feel better. And then maybe introduce jQuery, or maybe teach them about Canvas. And while it may feel a little tiny bit weird to jump right into DOM manipulation, it's again that visual component that kids really thrive off of when they're learning. And there's no one right way to write JavaScript. There's also no one right way to teach it. But I do have a few recommendations for you. So to build our tiny hacker army, first, we must bring programming principles into everyday life. And if this is your kid that you're trying to teach, this is a lot easier to do because you're around them kind of a lot. Chore charts become conditionals. If you complete your homework, you get a gold star. Instead of saying if you do your homework, then you get a gold star, start framing that in the language of programming. Start using those verbal cues with your kids. And if it's your chart and you can control it, make it look like a JavaScript conditional. Get creative. Get some syntax highlighting in there. Print it out. Get some emoji. Make it super awesome. It'll be the coolest chore chart in the world. Guys, startup idea. Chore charts with JavaScript. But to kids, conditionals are not super complicated to understand in their day-to-day life because it's basically a cause and effect relationship. You say, if you eat your vegetables, you get to have dessert. Then the kids, they get that. They get the cause and they get the effect. But when you sit them down at a computer and you try to get them to think about that in terms of programming, you have to wait until they're a little bit older to do that. But, start young, indoctrinate early. I'm just saying. And so while chore charts can be conditionals, school lunches can become arrays, and items in their lunchbox can have attributes. Their sandwich can have a type of bread. It can have a spread. Oh, that rhymed. And cleaning their room can become a loop. But I recommend maybe, if you're a little bit concerned about turning your kid into a super type A cleaner, maybe do a card game or dice game instead of cleaning their room as a loop. Just a suggestion. And start small. We're back to that vanilla JavaScript. Write a cute, tiny little function that draws a rectangle or a circle or a star even. and teach kids how to call that function with arguments. It's super basic, and there are lots of tutorials on the web for drawing shapes in JavaScript that are intended for kids that I actually will give you at the end of this presentation. And they're really great because they reinforce spatial reasoning in connection with programming. And little kids are pretty crappy at spatial reasoning. It takes them a long time to get that. And so if you're teaching them, you put in these two arguments and you get a rectangle, they change one of those two arguments, they can relate and they can see how the rectangle changes. And so you're wiring those spatial reasoning connections into their brain earlier than you might be able to usually. And once they know how to call those functions, you can maybe help them write one. I know, it's a big goal, but it's possible. And there's tons of great curriculum that is adapted to different ages, different learning styles that will help you with that. But really the number one question here is age factors. How young is too young? 3 is probably too young. It varies from kid to kid, but at the end of the day, these are the 3 most important things that you need to take into account when you decide to start teaching somebody's kid or your own kid JavaScript, or any programming language really. These are developmental markers that I was so happy I got to use my psychology degree when I was making this presentation. Yes. They need to be able to type accurately, or at least a little bit more accurately than me. And they need to be patient, not just patient in order to sit down and have this conversation and to learn, but patience for being wrong. They need to be okay with being frustrated, and that's different for every child. But the most important thing is that spatial and logical reasoning, which for most people doesn't kick in until their early teens, until about 13 or so, and that's when you can actually sit them down and they can write their own conditionals and write their own data structures. But before that, you might be pushing them a little too far. And so how do we do this? How do we actually make this happen? Plan. I don't know if you have ever watched Bridezilla's. Watch an episode, see the spreadsheets, see the whiteboards, see the Post-its, see the binders that these wedding planners have. Your plan should be better than that. I mean, it doesn't really have to be that intense, but you should have a really, really firm plan for how you want to teach, what your goals are. And don't expect it to be rigid. Just like anything goes with kids, you tell them they have to wear a jacket, but it's too cold, they don't want to wear a jacket. You have to be flexible. So build a plan and build flexibility into that plan. Don't be afraid to follow their tangents. They will direct their own learning in the direction that they want to go. And sometimes that's meh, but sometimes that's awesome. And set goals for those plans. You should have a long-term goal for why you're actually teaching your kid how to program, but you should also have shorter-term goals, little check-in points to see how you and your student are doing. A long-term goal, a great long-term goal is just to have some interest in the internet and how the internet works, or to get better at spatial reasoning. Those are good, solid, long-term goals. Short-term goals can be as basic as understanding a concept or being able to repeat that concept back to you in the future. The most important thing in the world is to keep the lesson short. Kids have short attention spans. A lot of people do too. That's why we all bring laptops to conferences. Sit there and you listen to somebody talk at you for 30 minutes, can get a little boring, and we start to want to multitask. Kids have an even shorter attention span than we do, so keep the lessons very short. Try to stick to 15 minutes at first if you can. If you have a slightly older child, or if they can type really well, or if they're wizards with data structures, please send them to Mensa and maybe make their lessons a little bit longer. But check in with them, keep an eye on how they're doing, and pay attention to how engaged they are. Stop the lesson if it's not productive. If you continue to push them beyond their comfort point, you've lost it. You've lost that entire day's work. Kids' brains aren't really cumulative. They kind of will just dump stuff out. So keep it short, keep it sweet. Boom. Resources. There's lots of stuff online, lots of visual stuff, and there's lots of actual code problems to teach kids how to do JavaScript. And my name is Liz Abinante. I'm feministy on Twitter. I'm super nice. Let's be friends. I work at Instructure in the Chicago office, so I'm so happy to be here because it's so warm. Anything else? I only got you guys out 3 minutes after 5, so let's go eat dinner.